Alright everyone, welcome to this question. This question is question 104, maximum depth of the binary tree. This is part of our blind 75 Leetcode playlist where we go through the blind 75 on Leetcode. So let's begin with this one. So in this question, we are given the root of a binary tree and we want to return the maximum depth. The maximum depth is equal to the number of nodes along the maximum path from the root all the way to the furthest leaf node. If you take a look here, the maximum path is 3, 20, and 7. So this is basically equal to 3 nodes, and so that's why the answer is 3. Here, it's 2, and we can actually visualize the tree here. So you can see it's just 1 and then 2, so that's why it's 2 over here. So this is basically a tree question. I think we can already see that. And the way I like to tackle tree questions is using recursion. You could use stack or queue, but recursion seems to be the easiest approach. And basically what I want to do here is I want to start off at the root. And usually for a lot of these questions where they ask for maximum, where they ask for minimum, when they ask for like min distance, max distance, etc., I find that it often helps to keep a separate variable to kind of keep track of that answer that you're looking for, sort of like a global variable. And so then your actual recursive function doesn't really need to worry about that. Your recursive function simply needs to worry about going down the tree and calculating the maximum path from that certain location, whereas your global variable will keep track of the overall answer. So just to kind of show you what I mean, let's just go ahead and start coding this, and then we'll kind of go through some of the challenges or some of the um, problems we might run into and how we'll solve them. So let's go ahead and start this. So with any of these questions, it's often a good practice to just handle the case where root does not exist. So if root does not exist, then it makes sense to just return 0 because there are no items, so the maximum depth is 0. Otherwise, what we want to do is let's just create our answer variable. I'll just call it result, and I'll keep it equal to 0. And then I'll do a helper call. So this is my recursive call. And then in the end, I'll just return my answer variable, my result variable. So basically, now in our helper method, which is a recursive method, what do we need? Well, we just need the root actually, in this case. And often for these tree questions, the only thing you really need is a root most of the time. You won't need anything else. Now, as with all tree questions, it's a recursive question, so we need to handle our base cases. So what are some of the base cases here? Well, let's see. So if root does not exist, then that's a height of 0, or it's a depth of 0. If root does exist, but it's a leaf, so if not root.left and not root.right, so this means it's a leaf, so something like 7, then the answer is going to be 1. Otherwise, what would the answer be? Well, let's take a look at something like 20, right? For 20, it has left children and it has right children. If I want to find the longest path along, from 20, right? What would make more sense? Well, what would make sense is I want to find the maximum path that I can reach from either 15 or 7. So I want to find the maximum from my left-hand children and from my right-hand children. Because maybe this goes all the way down, but this doesn't go that much down. So what I can do is I can find the maximum between these two children, and then once I have that, I will add in the number 1, basically find the maximum, with 20 included. And so that will be my answer. So the way you can kind of think about this is you can do a left-hand recursion. This will be with root.left. You can do a right-hand recursion, so this will be with root.right. So now when we're at 20, we'll recurse on the 15, we'll recurse on the 7, and then we'll basically calculate the maximum of these two. So we will do maximum left and right. So this will give me a child that has the maximum depth along its root and downwards, and then we will just add in 1 for the 20, right? And so then this will equal our new depth, right? And so basically what I want to do is I want to return this depth in the end, right? Because from 20, 3 is the one that called 20. So I need to return this depth to 3. But also what I want to do is I want to store this in my global variable here. I would do self.result is equal to self.result and then depth. And so that's all there is to this. And then in the end, I will just call this with my root. And then I can try this with my example test cases. And then I will try this, everything. And it does not work, and the reason is because the 0, 0, it's giving me a 1 and it's giving me a 0. Okay, so the reason is because if we do something like self.res is equal to 0 and we're returning self.res in the end, well, if we just have a leaf, right, then we haven't had the chance to update self.res because we updated down here. So we can just actually do this. We'll do maximum self.res and actually just one in this case. So we'll click submit over here. And so that should take care of everything. So again, this is how you do these types of questions. Basically like to have a helper function, like to have a global variable, which is self.res, which does not change, and then like to do it in this sort of format. Anyways, thanks for watching. Oh, and before I go, actually, let's just discuss the time and space. So usually with all these types of questions, the time is just a number of nodes in the binary tree, whichever that might be. So log base 2 of the height in the worst case, because it might be like a full binary tree. And the space, really, if you want to consider stack space, you can, but just confirm that with your interviewer. Otherwise, space doesn't really matter here because we're not storing any set or anything like that. Yes, this was the video, and I hope you guys learned something from it.